Hello there, it's Jay here from Jay's Vintage Junk, and today I thought we'd have a crack at this. If you watched my previous video, this is the Quad 303 that I have down in my office, which I was going to demo that sound desk that I've just repaired on, and I plugged it in and it released the magic smoke. So I thought what we'd do in this video is crack inside it, have a look inside it and see if we can actually find out what's failed. I'm not promising we can actually repair it on this video, but at least in this one we can have a good look inside it, like I said, and have a look what condition the capacitors are in. See, hopefully there's nothing major failed in it. I'm just hoping it's a bad capacitor or something like that. I really hope it's not like the mains transformer or something more serious that's gone, but anyway, we won't know that until we get inside it, so let's crack on and do that. I think we have to remove these screws from the bottom, and that should release the top case. I don't think we have to take the feet off. No, I don't think we take the feet off. I think we just take these other 4 screws out. So let's put that foot back on. I think what happens is we take these out and the ends slide up, and then the whole cowling comes off. I'll have to dig my other quad amplifier out. I've got a Quad 50 kicking about somewhere. There's another transistorized solid state amplifier, but it's like more of a professional thing. It came out of a old theatre. It was actually what was used for the show relay in an old theatre that we was refurbishing, and it was going again. It was going to e-waste, so it went in the back of my van instead. But that one is there. Oh no, the bottom just drops off. That one is in much worse condition than this. That's been horrendously bodged over the years to keep it going as well. Like I said, this is should be quite fresh, and I already spot. I don't know if you can see this. We do have some blackening there, so that's the back of the amplifier, and I do believe that the smoke seems to emanate from the front, but that doesn't mean anything. It can always travel inside. Let's get the cover off, and then we'll have a close look at that board there. Let's get the cover off anyway, so I want to have a look what state the capacitors are in. This is a heavy beast. It really is a heavy beast. It's all die-cast frame. I mean, these quads were built like tanks, they really were. This is proper British engineering. Done properly, done right. Ugh. Right, let's see if we can get this cover off. Come on, off you come. There we go. And we're in. Put that to one side. I can't see anything too disastrous from up here. There's obviously the diode block. We've got our main smoothing cams, and to be honest, I think they're original, and they don't actually. There's no bulging to the top of them. Usually, when these type of cans start to fail, you start getting a bulge on the top of them where the vent is, and the rubber on the top is, look at that, that's a bit firmer, but these are lovely. Look at that, it's like a bouncy castle. So there's no vent, you know, they're not, let's see if it's that side, there it is, and that one. So there's no pressure built up in any of them capacitors. They're I think they're probably going to be absolutely bob on. Well, I will check them for capacitance, but so when these start to fail, usually you'll see that little pip there swell up, and if you push on it, it'll feel hard because there'll be pressure in the can. These obviously, you know, they seem in good condition actually. So let's get back over here and let's pull this board off, because that's obviously where we've seen some. There is some heat damage there. Hopefully we can figure out how this board comes out. I think you literally just have to lift these clips up and pop it out. There we go, that's that side out. I bet, yeah, I have. I've taken the side out I should have left in, because that's the side with all the wiring on it, but never mind. Just ease it up, ease it up, ease it up, and let's see what's there. I can't see what's smoked there. Certainly got very hot round here. Looks like that resistor there. Could that transistor may have shorted? I'm not sure. I think we'll pull the rest of the boards out and we'll have a look. But that's where all the heat damage is. It's round here. It's got a big transistor there. That's a RCA part. Let's have a look at some of these other boards. That's broken off on that side. Now we do have some capacitors there which are known to cause issues, which are these. So potentially we could have a bad cap in one of them. They're probably worth replacing while we're in here. Let's get the final board. Again, this one's it's flopping about a bit. Oh, some of its clips have failed over the years, and that's actually broken at that side there. So these were literally thrown out. So I'm actually surprised they didn't sustain more damage. Again, we've got them 3 capacitors there, which I think are probably well worthwhile changing. And we're going to have to test these transistors. These are the preamp transistors. The power amp transistors are actually down here on this big heatsink at the back. I'm hoping one of them hasn't failed, to be honest. Hopefully not, because there's rather a lot of them. I think you can get to them by taking this plate off the back. But yeah, let's have a think about this. I'm definitely going to change them caps, but I think I'll get a meter out and we'll just see if any of them caps are actually shorted. Right, we've got one there. It seems okay. Another one next to it. Oh, I think that may even be virtually open circuit. It certainly doesn't sound very happy, does it? Let's try the same on this side. That one seems alright, seems to be charging okay. Try this one. It could just be that they're very low value and they charge incredibly fast. Possibly. And the other one is that one there. Again, it could just be a very small capacitance. We have no capacitors on this board, well, apart from that, which I don't think is going to be the issue. These usually don't fail. Quite a resistance. Let's see what we've got on the resistance range there. We've got about 3k across that capacitor there. So what's that feeding to? Everything in this is loomed as well, so it does make tracing wiring a little bit of fun, I must admit. Is it one of these power rails? No, they go down. Everything is colour coded as well. So that blue wire there that we're interested in, that red wire there, because they both go, yeah, they've got, no they don't, sorry, it's that purple wire there and that red wire there both go right across that capacitor. So where does brown and purple go? And the ones without stripes on, because everything in this thing seems to be very well colour coded. Let's have a look at the other side where the rectifier and the capacitors are and see if we can spot it on there. Two blue there AC from the transformer. That's the output from the transformer there. So that's the DC after the rectifier. We can test the rectifier. Have a go. And then let's go back down onto diode test. Because that's across the coil, so definitely the transformer seems alright. That doesn't seem right. I may have to pull this this out of circuit to actually test it properly, because we could just be charging them capacitors up. I don't know, that seems okay. Nothing that way. Let's top it round. I think that's just them capacitors charging up, we'll see. Try it the other way. Nothing. No, so that's okay. The diode block's alright. I think these capacitors are alright. Yeah, they seem okay. You can see them charging up when you've got the meter on them like that anyway. There's no dead shorts there. Yeah, they're all charging up. Seem okay then. So none of them are, certainly none of them are dead short. These charge up and then go high resistance once they've charged. See if this one does the same. That one might be a little on the... oh no, there it goes. Well, so I think they're all okay. So we still need to find out why that red and that brown, we've got 3K across that capacitor there. Let's trace the rest of this circuit out and have a see, because this is certainly where the issue lies. Now, one side of it, oops, all my meter leads have got all tangled up. Hang on a minute, let me just untangle my meter leads. Right, so we've got the red and the brown there. We need to really find out where the red and the brown go, or where they're fed from. Now we have a red there, and we have a red there. So see, we've got a connection between there and there. 0 ohms, yes, so that's connected to the same point as that. Let's see if this one is as well. Exactly, yeah. And then this, there to there. Well, that's charging a capacitor when I do that, so there's obviously something, but when I go between there and there on here, now that seems to be charging a capacitor. That's interesting, because before, when I was doing that, I was getting just 3K between these 2 points. So what could have caused this overheating here? Now we've got that transistor there. That could be a suspect. Let's see if we can test the transistor. Well, that seems alright. Let's try the other two sides on the transistor. Ah, I know. Wait a minute. I'm shouting something out there. Let's put it in a place where we can get to it and we can test it. I've got nothing that way around. We have got it that way around. And we've got nothing that way around. But we have got it that way around. So yeah, I think that transistor's alright. At least it's passing the basic test for a transistor. We can test this little transistor here. That's a tiny little thing. But nothing that way around. We've got something that way around, and we've got something that way around, and nothing that way around. So it looks like the two transistors are working okay. Now that certainly looks like it got very hot. But it seems to be it's not open circuit anyway. I'm not sure what value it should be. It seems to have some capacitance across it because it seems to be charging on the meter. That should be is that 330 meg? That sounds a bit ridiculous. This is 330M on it. Oh, it could be a capacitor actually. Looking at it, it could be a capacitor. Let's have a look. Well, that doesn't. The burning seems to be around these components here, but I can't actually really figure out what. That obviously runs hot because it's on little ceramics. Am I chasing the wrong part of the board here? Is this just natural discoloration from the run near this board? Well, that's not open circuit. Should I be daring and run this up open on the Variac and see if we can spot what smokes? That's one thing we could possibly do. I can run it up on the Variac as it is, like that, and wind it up and see what starts to smoke and smoulder. And at least we can then trace where the start of the fault is, and we can take it from there. I think that might be one of the easier ways of actually figuring this out. Or should we test the output transistors first? I mean, that would be the more sensible thing to do, I think, would be test the output transistors, make sure none of them are actually faulty. In fact, yeah, let's go for the more sensible approach, and we'll have a look at testing the output transistors first. And if that doesn't show anything awry, then we'll do the old fire it up, wind it up on the Variac and observe where the smoke comes from. It's always a fun way of doing it, but this is rather an expensive piece of equipment, and obviously I really don't want to damage it. I do want this back in nice working order. we'll do the sensible one first. Take that off there. You see everything, like die-cast back cover for the power transistors. Proper quality. And we've got 1, 2, 3, 4, 5. Right, okay, 5 RCA power transistors. All properly done with heatsink compound. It looks like none of these have ever been oh, I don't know. Unless that's a different one. Is that something, a driver, and we've got 2 push-pull for output? I'm not sure how this is. I must admit, I should have really dug the circuit for this thing out before embarking on this. But you know what it's like. You get so far, and I think I will have to dig the circuit out, to be honest. But for now, there's things we can definitely do before we dig the circuit out. Like I said, we can definitely have a look at these power transistors and see if any of them are shorted. See if I can take this whole back heatsink off. It might make life easier for actually getting to them. Oops, yeah, there we're off. Hopefully didn't break anything then. Right, there we go, can you see that? I'll zoom in a little bit. So that's the back of the power transistors there. We can now go ahead and test these. So that's the ground there, we'll go on that side. And that, we should have enough. Oh. Well, that's not good. We could have a bad power transistor here. Because we shouldn't get a short like that in all directions. So what I might do is just whip these wires off here and just test it out of circuit, because you can't be sure it's actually this until you've actually tried it out of circuit. So we'll just whip the wires off so it's black to the bottom, then purple with a red stripe. Oops, we pulled a little sleeving off that as well when it come up. We can stick that back on. That just stops it short into the casing. Go on, back on you go. There you go. Right, now we can do a proper test, because that didn't look good with that connected there. And this is testing better. Oh. Or maybe not. That seems okay. That's right. But this side, we get nothing. Nothing at all on the meter. So we could have a bad power transistor there. Only half of it seems to be working. What I might do actually is I'll pull my other transistor tester out, my El Cheapo Chinese one, because it is actually quite good at identifying transistors. Yeah, it's working at the moment. So we can clip this onto it and we can actually test that transistor and see what this makes of it. So if it comes up as a diode, I think we know there's something wrong with this transistor. And we'll have to find a replacement. which may be easier said than done to get something that's exactly right. MPN, no, it seems to that is coming up and that's happy, that's absolutely right. Yep. So probing around with a meter can sometimes send you on a merry dance. So you can, oops, that didn't. There we go. That one's on. Right, okay, they're connected back up. Wonder if I can test them in circuit with this. We'll give them a try. I'll see what it makes of them. A broken crop clip on there. I'll have to replace that. That's on there now. That's on there now, so let's try that. Device unknown. Let's try the next one up. See if this comes up as device unknown. Or is it just because we're trying to test in circuit? I'm not sure. That's really not sure. I think that's charging a rather large capacitor up. Yeah, I can't really do this with this on in circuit by the look of it. So I think what I'll do is I'll pause the video and I'm going to go through all these transistors and just desolder them like you've seen, like I did with that one, and test them, and I'll get back to you there after I've done that. Okay, well, I've tested all the output transistors, and they all test absolutely fine, so I don't think that's the issue. So we're on to basically what I'm doing. I'm going through the things which are most likely to cause some smoke to be emitted. And one of the first things I thought was, if you get a short power transistor, that's going to burn a resistor or something. I've already tested the rectifier diode. That's okay. So that means it wasn't the mains transformer that was getting too hot and starting to smoke. And I can't actually see any seriously blackened resistors either. This is quite strange. I'd expect to see, apart from that one bit of overheating there, but the resistor's still okay. I'd expect to see something slightly burnt and blackened in here, and I'm not seeing it. It's going to be where here we go. We've spotted him. Just pan the camera over, get you up there. Let's zoom you in. Oops. Can you spot him there? Right down there. I don't know if you can see it, but we've got a very blackened resistor there. Fortunately, these boards are identical. So even though we can't read the value on that one there, we can certainly read the value on that one that's, sorry, can't see, like I said, these boards are identical, so that's the blackened part there on this board, and that's the good part there on that board. So we can measure the value of that, and we can find out what it is, and we can replace that. But more importantly, what we need to find out is what's caused that. Let me zoom you out again. I need a remote for this camera. Unfortunately, I don't think it even has that ability. What we've got to find out is why has that gone pop? Because resistors don't usually just burn up like that. They usually have to have a cause for them to burn up like that. So that's what we need to find out. It could be this transistor here. It could. let's have a rummage round on that. We could have a faulty transistor here. Get you down here. That's the transistor nearest. In fact, let's have a quick look on the back of the board and see what we can figure out. So, got that capacitor there, and then here is where that resistor is connected there. I believe that's the top and that's the bottom of the resistor, if I'm right. No, that's the wrong one. It's further down here. Aha, it's there. That's the resistor, and it does indeed go to that. It does indeed go to that transistor there. So I think what we might do is whip that transistor out of the board and actually see whether it's all right or not. I think the easiest way of taking that out, we're going to have to take the heatsink out. That's quite a beefy transistor. That could certainly cause that. If that had failed, it could certainly cause that to smoke. So I think we're going to have to whip this heatsink out here, whip the transistor out, and we'll test the transistor out of circuit. We're going to have some fun getting that out of here. Where's my little box of stuff? Let's see if that's going to be the right size. Yes, it is. Dear me, they're thread lock. Oh yeah, I think we've thread locked them in or something. Right, I forgot I can hold this with. Let's get out of the pair of pliers. That's that one free. That's that one free. Okay, out you come. We'll get this top of this heatsink off. Come on, out you come. There we go, that's out. And we will desolder that transistor there and get that out of the board. Where's my flipper gone? Right. Oops. Dropping everything on the floor. Right, out you come. Right, let's see if that's going to budge. Come on. You're going to be an awkward little sod, aren't you? It's definitely going to be an awkward little sod, this one. That side's free, that side's free. It's just this one here is being a little on the that should come out, that. There we go. Just need a little persuasion. Right, and that's the transistor out. We can give that a test and just see whether it is working or not. connect the meter up. You can see me down here. Where are we now? There we are. Right, let's connect the meter up to it. That one's broken, I have to just hold that on, I think. Unless I can reset it. I have to replace this crocodile clip. Right, that's all there and nothing's touching. Press on the tester. Nope, indeed that seems to be testing fine. It's going to be one of the other transistors round here, I think, which is short. We'll put that back in a minute. Because having it out will certainly help us eliminate what else it could be. What else could it be? What could turn that transistor hard on? Which, I mean, it is a beefy transistor. I don't think too much would kill it. It'd actually take quite a bit of current before it bit the dust, and I didn't have the amp on for more than literally a few seconds before I realised there was something wrong, and it got shut off nice and quick. So, it could be one of these. I don't see it being anything to do with that electrolytic. What's that there? What's that connected to? That's another resistor there. That's not smoked. That goes across to there. That's goes to that transistor there. See if we got any shorts on it with the meter. That could have a short on one side. Obviously, it's not the best way of testing a transistor, that really, but there could potentially be a short on that transistor there. Sorry, you're not seeing it again, are you? This transistor here, which is associated with that transistor. So if that transistor was shorted and turned that transistor hard on, so that's quite a beefy transistor, and that could have potentially taken out that resistor. If I don't find it, I'm going to whip this one out, and if I don't find it, then I'm actually going to bite the bullet and go and print out the circuit diagram for this thing, and then we'll take it from there, and we'll have to do it a little bit more in depth. What we are definitely going to do while we're in here doing this is we are going to change them capacitors out, because like I said, they are a known they are a known capacitors to definitely fail. But before we do that, I'm just going to, just as a last guess attempt, because I am just guessing at things on this, I am going to just whip that transistor out and give that a quick test. Come on, out you come. There we go, out he comes. Let's give this a little boy test. What have we got here? Oh, it's a ZTX 504. Now, let's see what this says on the capacitor, the transistor tester. That says it's fine. Yep, it looks like I'm going to have to pause this video, and I'll have to go and print some service data out for this thing, and we'll take it from there. So back shortly. Okay, I'm back, and I've printed myself a copy of the circuit diagram. I've printed the basic service manual for it here. Easy enough to find online, so not a problem. And I've identified the resistor, which is this one, which is the one that actually blew. It's a 10 ohm resistor, and it's R126 in the circuit. And R126 is here. If we look, it's on that there. And what it basically does, it's on this transistor, and this transistor is one of the driver transistors, which actually drive the main two output transistors. They're push-pull basically. I think one's NPN, one's PNP or something like that. And you have the same as like a driver pair that drive them too. So you've got, I think it's those are the drivers. No, sorry, those are the drivers, I think, for that side. Those are the drivers for that side. And it's R126 there is the resistor that's failed. Now the thing is, what I've done is I've basically tested the transistors. I tested the, as you saw before, the main output transistors, and they're fine. I tested that transistor there, which is that metal cased one that we pulled out. That's fine. I tested that, which is the TZX was it 4 or 5 something. Anyway, that one was fine. While the video's been off, I've also tested that diode there. There's a couple of diodes, the Zener diodes in the circuit here, and they test out okay. I have compared resistance readings all around here between the faulty board and the other board, which I presume is working. That's certainly not smoked. And to be honest, I can't find any difference. I can't find anything between this board and that board when I check for like resistance readings between various points. I check for short circuits on the board or anything, and I cannot find any difference between the two. This is getting most odd. What I may end up doing actually is replacing that. It's very, very rare for a resistor just to fail like that, but occasionally it does happen. And where it is in the circuit, that resistor is probably actually going to be driven quite hard. It's only a 10 ohm resistor, but I think it'd have probably been run quite close to its tolerance all the time. And I'm wondering whether literally the resistor did just give up after all the years. So what I'm probably going to do is stick a new resistor in there and run this thing up on the Variac open like this, and we'll just see if a new resistor starts to smoke or not. And then we'll obviously we'll put a signal up it and connect some speakers up to it, and we'll monitor everything while we're doing that, and actually see if we can find out what's failing, because every reading that I take between the two boards is seeming absolutely fine. It's a bit of a perplexing one, this. What I will also do is I'm going to change these capacitors before I go any further, because they're not failed at the moment, but these capacitors are known as little buggers for failing. So what I think I'll do, I'm going to do a part 2 of this. This video's already gone on quite long, so I'm going to leave it here for now for this video. And when I get back to it, we'll put a new 10 ohm resistor in there. We'll change these electrolytics out, because I know that they cause issues. They're always failing in some of the old TVs that I work on them. I don't think there's anything on that board that really needs changing. We'll just no, that board's okay actually. No, it's just on these two. Well, like I said, we'll change out them electrolytic caps. We'll put a new 10 ohm resistor in on there. We'll connect some speakers and source up to it, and we'll wind it up on the Variac, and we'll see what happens. It could just be that resistor failed due to old age. Like I say, it's very unlikely, but I can't find any cause. Like I said, I can't find a shorted transistor where I'd expect to find one around this part of the circuit. I can't find any more burn resistors. I can't find a bad diode or anything like that in this part of the circuit. So I think really that's the easiest thing I can do. Is, like I said, swap that resistor out there, and we'll fire it up and see if that resistor burns up. If it does, we'll pull the resistor out, we'll fire it up once again. We'll have to start taking lots of voltage readings and see whether we can actually find what's going on here, but we'll try that for now. Well, like I said, that's going to be in the next video, because this video has already run on for too long. So I'm going to say thanks for watching for now, and goodbye.